All right, good afternoon, everyone. So today we are going to discuss about pulley. I want to stress several things on pulley, during the solving of these problems. So when you're having a problems like this, what you need to see first is where's the load at, and then starting from this load, you then try to solve the other pulley. Yeah, so for example, in this case, the load is given on pulley A, so you start working on pulley A first, and then go to pulley B, and then go to pulley C, even though the problem asks you to solve for pulley uh pulley T, right? Pulley C. Okay, so first we need to solve from A. Yeah, we need to draw a free body diagram of pulley A. Okay, and that pulley A, you will have this, let's call it I don't know, let's call it T1, and here T2. Yeah, you might have you might think that, opa, but T1 and T2 shouldn't be the same all the time. Yes. Yeah, but how to prove it? Yeah, as a mechanical engineering student or aerospace engineering students or materials engineering, we are we are learning to use the principle of mechanics to solve this. Yeah, not just by intuition. Oh, because this is like one rope that is connected, so I guess T1 should be equal to T2, right? No, I don't need your guess there. You will need to solve by mechanics. Yeah, so in this case, how to prove T1 equals to T2? And here there is 1,000 pound. Yeah, how to prove if T1 equals T2? If you take a look at this clearly, this one, let me choose this color. The radius is R, and this radius also R. So if you take the moment right at the center, yeah, sigma moment at the center of the pulley A, yeah, equals 0, it means that the T2 will create clockwise. So minus T2 times R plus the T1 will create counterclockwise. So it's positive plus T1 times R, okay, equals 0. Having said that, your T1R equals to T2R, so your T1 equals T2. That's how you prove that. So it is one rope, the T1 equals T2, and that's how you use equilibrium equation, sigma moment equals 0, and to solve this, that T1 equals T2 finally, right? Okay, so and then how to calculate T1 and T2? From here, you see that if we say that this is the X coordinate and this is the Y coordinate, you can write down that T1 plus T2 equals 1,000. That's coming from sigma Fy equals 0, right? Since T1 and T2 are equals, means T1 plus T1, right? Because T2 is T1. 2T1, let me write down directly like this, equals 1,000. Your T1 now 500, and also your T2 is 500. Okay, and then this is at pulley A. Yeah, pulley A. Okay, I hope it's clear. Yes. Now what we need to do is to move to the pulley B, since the pulley B above pulley A. Let's write down here, I guess, right? And this is the center. So, and then there is this counter load, which is T12, yeah. because action and reaction, so the direction should be opposite. And then for B, there is a, let's call it T3, and then let's call it T4. All right. And then if you realize they also have the same radius R and R, so it means if you take sigma moment equals 0 again, yeah, the same way you proceed, you will prove that sigma moment at B equals 0, yeah, B means the center of the pulley, yeah, you will prove that the T3 equals T4. Then if you see here, sigma force y direction equals 0, then the T3 plus T4, T3, they are equals to T1, which is the opposite direction, right? Whereas your T1 is 500. Okay, so and then your T3 equals T4 equals 250. Okay, and that's the second finding because of pulley B. All right, and then what else? What else? Then let's move this a bit downward. Is it possible? I guess so. Let's move a bit downward. Okay, and then let's solve for pulley C. Yeah, pulley C. Pulley C. Pulley C means pulley C, not policy. In Indonesian, we have policy. Policy is police. Anyway, pulley C. Let's draw. This is the pulley C. All right. And then at pulley C, since this is like pin joint, right? You will have CX, CY, yeah, CX and CY. At pulley B and A, and the X direction can be ignored because you know it can move in the B direction, right? In the X direction, I mean, for both pulley A and pulley B. And then you have this like this T, right? And this is T4, right? So we know that T equals T4. Am I right or wrong? I think I'm right. Because if you take a moment at C, so anyway, so if you see here, it's R, and this is also create R. So if you take sigma moment, if you take sigma moment at the center of C equals 0, the CY and the CX will not generate any moment. The one that generating moment is T4 times R from the tangent to the center of the pulley minus T times R2 from the tangent to the center of the pulley equals 0. And then your T will be T4, which is 250 pound. Yeah, 250 pound. That's it. Okay, it's very easy. Yeah, it's very easy actually. Okay, that's how you solve correctly by mechanics. Yeah, if you are expert later, if you're expert, and it's very easy. So this is 1000 because this is one rope. I mean, this 1000 divided by 2, this is 500, this is 500. Yeah, and then because this is 500, and then it's evenly sustained by this 2 rope, so this is 250. this is 250, and this is because this is one row, means that T is 250, right? Very simple. You get directly, not even 30 seconds, but that's not how a mechanics students work. Yeah, you need to prove by using the principle of equilibrium moment, equilibrium force in y direction, in x directions. Yeah, okay. So it's very important that not only be able to solve the number, but to implement what you have learned, implement the theory, the principle of equilibrium, the Newton's law. Yeah, okay. I think that's for the first problem on pulley. I hope I can give you another example of pulley problems in the future. Okay, let me know if you have any question in the comment sections below. Okay, see you. Bye.